Mm-hmm.
Hmm.
Okay. So, mm, welcome everyone. Today we have our host speaker. Just let me introduce him. His name is Salim. He's a biology teacher at New York. Like which region in New York, Salim?
I
Do you
live in
live?
Manhattan.
Yeah, in Manhattan. Yeah, like you can ask some questions about Manhattan and like about the part of New York, like some cultural stuff.
So,
I think Salim will be more than welcome to answer these questions.
absolutely.
And yeah, he's going to share about his experience, and he will introduce everything by himself now. So students, just to confirm, do you hear me well?
Yes.
Mm-hmm. Okay. So, Salim, mm, should I start from this slide?
Sure. So thank you everyone for taking the
Mm,
time to listen to me. I hope I wanted to share some stuff that I had been recently doing. I've been teaching biology for the last 20 years uh, in middle school through high school, so 6th through 12th grade. And one of the things that I uh, think is very important to
mm.
focus on is
Salim,
the,
sorry, just give me a chance to record it.
yes,
Then
of course.
afterwards, yeah, I will be able to send you the recordings, okay? I send request. Please confirm it. You you get the, you can make me a host, okay? Yeah. Okay. I think it's recording now.
Yeah,
Did you get the recording notification?
I am recording. Yes, I'm.
Okay. Okay. So, everybody, mm-hmm. Yeah, Salim, you can start
Okay,
and
thank you.
go. Mm-hmm.
I've been teaching biology for the last 20 years, and the thing that I've come to focus on is this idea that a lot of times when we teach biology, that we are telling students uh, what has come before, but we're not asking them to actually observe reality in any meaningful way. So they have to take my word for so many things as opposed to independently observe this. I think that's a little bit different than what I've observed in chemistry and in physics, where you are able to learn from first principles and you're able to observe phenomena clearly for yourself. Biology does not tend to do that, which is a pity because there's so many beautiful and exciting things out there to observe, ideally directly, but even indirectly, you're able to learn an incredible amount just by paying close attention and using your what you observe to understand larger ideas. So this paper that I recently wrote in collaboration with the E.O. Wilson Foundation in the United States uh, was the idea was to learn how to observe environments where it is difficult to directly observe them. And so one of the things that we have sort of discovered was one way to observe very difficult environments is through soundscapes. So a soundscape is like a landscape, but it is the sounds that you are able to hear in a given environment. Uh, so a sound can be an incredibly valuable way to uh, gather data non-invasively and non-obtrusively in an environment. With the proliferation of inexpensive audio equipment and large storage capacity, and with the ability to use AI to identify individual sounds, we're able to gather a tremendous data boom of environmental soundscapes now. And so, given that is a sort of cutting edge uh, technology, it's worth teaching students about this also because it's interdisciplinary. This is one of those topics that uh, obviously cuts into biology, but also into physics as well. So let me ask you a little bit, just looking at these two different images, just uh, I would love to ask just obviously there's some obvious things, but what would you imagine would be the differences in the sound of these two places? Uh, Sabina.
Differences. First picture, a lot of elements. Mhm. And
What what kind of
more
sounds
brighter,
would be different?
and they are more brighter than second picture.
Yes, it is. So you can see visually, it is
Mhm.
brighter colors. But what about the
Yes.
sounds? How will the sounds be different?
Mm.
What kind of sounds do you think you'll hear in the first image?
Hello, teacher. My answer.
Yeah, please.
And for me, the first picture is somehow rigorous and it's full of energy for me. And the second picture is like from a horror movie.
Yes,
Something scary sounds for me.
I like that. Yes, the sounds you're absolutely right. The sounds will be very different, and those are sounds that we can record and we can see a total difference. So one of the things that I like to compare this to is think about the sounds that you make when you're healthy versus when you're unhealthy. So like you think about when you're sick, you're making all kinds of there's all of this data that you can get from listening to someone's uh, sounds, and that's sort of the soundscape of a healthy body versus an unhealthy body. There's a soundscape to a healthy ecosystem versus an unhealthy ecosystem.
Mm. Like,
Um, yeah,
sorry for interrupting you.
please.
It reminds me when you are breathing, like
Hmm.
healthy people breathe is like, very calmly and quiet, but
Yeah,
yeah, some kind of, like unhealthy people, it like ejects some kind of sound. Yeah, like
yeah,
some kind of like, yeah,
and everybody knows it. Yes,
yeah.
that's exactly right. There's uh, in that sense you can it's not the most rigorous quantitative tool. Like you're not measuring, oh, someone sounds 10 times sicker, but you're able to qualitatively understand there's something about the homeostasis of an individual through their sound. Likewise, you can understand that there's a difference in the homeostasis of the uh, ecosystem by hearing the differences in the sound. So I give this to students, and the first thing I make them do, because obviously we're not going to a coral reef, is I make them draw these. And drawing is a tool that I have my students use a lot because it forces them to spend a lot of time looking at things and paying attention. So they can describe things like the colors that they see and the shapes that they're seeing and the differences. So, at first their observations are very basic, like uh, there's more stuff in image one. Well, okay, well, what do you mean by more stuff? Well, oh, there's more fish. Okay, what are the shapes of the fish? What are the colors? And then the more they start to describe, the richer the details they are able to write about, and then we can use that to understand the differences that we are observing when we also listen. Um, are you able to go to the next one, Nurse Hassan? I can't. No. Okay. Thank you.
Okay.
Yeah. All right.
Like, is
Yeah.
it a whole
So
picture?
right here.
Is
Yeah. So uh, in a in the soundscape uh, vocabulary, we uh, distinguish sounds into three categories. This is how we help students to use technical vocabulary to explain things more richly. So the three terms that I introduce students to are the idea of biophony, geophony, and anthrophony. So biophony would be the sounds that living creatures make, whether it's a cat meowing or a dog barking. Anything that a living creature would make would be a biophonous sound. These are not words that we would use in our daily uh, discussions. It would only be used in science. But what I like about this kind of terminology is for this particular discussion, it enriches the discussion because now I'm not just saying, oh, I'm hearing a loud sound. I'm hearing a loud biophonous sound. I'm hearing a sound that is very clearly a sound from a living creature as opposed to a sound that is from the environment, like I said, it's here waves crashing. Um, hey Donna, what would be an example that you could think of a geophonous sound?
Maybe wind sounds.
Yeah, wind, absolutely. The sound of wind would be a geophonous sound. Very nice. And then we have these anthrophonous sounds, which would be the sounds that humans make or that human technology makes. Um, and so let's just, I'm curious, let's think about it together with just without listening to any particular sound. When you think of an anthrophonous sound, um, Ismail, what comes to mind?
Uh, since you said that the sound of human activities,
Yes.
what comes to my mind is like anything that human beings are doing. For example, let's say driving a car,
Yes.
those sound of the car.
Okay. So what do you like that? What does that sound like? Does it vary a lot? Is it very loud? Is it like how could you describe the sound of a car driving along the street?
Also, sometimes it depends on the type of the car or the person that is driving.
Yes.
Some people are very gentle and they
Sure.
care about others, so
Sure.
they don't have this kind of, how do you call this, disturbing behaviors. I can say
Okay.
like that.
I like that. Yeah.
But
So there is.
some of the people living in the street, those people that they like to like do this kind of thing, what the meeting together, maybe
Yeah.
show off,
Hmm.
their cars are making enough noise and
Yeah.
disturbing.
Yeah,
Excellent.
sometimes BMW drivers make a lot of noise.
Yes. So we can distinguish this idea of and this is how we get into more detail. We can enrich the discussion by talking about the volume or loudness levels. We can also talk about the pitch of sound. So there's lots of different ways to increase the rigor and richness of how we describe things. But we could say, for example, that anthrophonous sounds in general tend to sound very consistent. When you honk your horn, it sounds the same pretty much every time. If you honk your horn for 2 seconds, it's not going to be varying in its tone. Whereas a bird singing, how would that be different? Sabina, like what would you say about the
Repeat
pattern?
your question.
Sure. So let's say a bird singing, a biophonous sound. How does that
Mm,
compare to an anthrophonous sound?
mm. Yes. Biofilm and the marine life and the uh-huh.
These are tough
Mm,
terms. They're not ones that you've probably ever encountered before. So maybe, for example, birds singing, they don't always sound exactly the same, but a horn honking, your car, if you honk the horn, it will sound the same every time. But a bird singing is not going to sound exactly the same every time. There's going to be differences in pitches. There's variation to the sound. So we can figure out by looking at the variation whether a sound is likely to be biophonous, geophonous, or anthrophonous. And we can do that as an activity with students by listening to various sounds.
mhm.
So we can hear, for example, you can think about it, some people really like the sound of rain at night. That kind of that consistent pattern is soothing for some people. Or the sounds of waves coming in and out is very soothing, and it's very soothing because it is very consistent. Life is not nearly as consistent as the sounds of the earth. And I guess the sounds of machines are also pretty consistent, but they don't tend to be very soothing. I think machine sounds are ugly, as Ismail generally said. Uh, so given that, Nurse Sultan, do you mind going to the next slide,
Yeah.
please?
Mhm.
Yeah. Yeah. When we think about a healthy ecosystem, what kind of sounds would we expect to hear? How much of these sounds would we expect to hear in a healthy ecosystem? Oh, in a healthy ecosystem, there's probably going to be all three of these sounds because human beings are everywhere. And while we generally do make a lot of environmental damage, we're not only making environmental damage. So in a healthy ecosystem, you can hear all three of those things. In some places we might be the sounds of human machines will be minimal. So, deep in the Amazon rainforest, there probably will not be a lot of anthrophonos sounds, or deep in the ocean, there'll be no anthrophonos sounds. But you will always hear biophonous and geophonous sounds. So you'll be able to sort of distinguish between those. So overall, we can say that a healthy ecosystem will have some intersection of uh, biophonous and geophonous sounds, and maybe anthrophonos sounds. It doesn't. Healthy ecosystems can have uh, anthrophonos sounds. There can be, like whale watching or birds. The presence of humans does not automatically make an environment unhealthy. But we can also say that the overabundance of anthrophonos sounds is probably going to indicate a less healthy environment or a less healthy ecosystem.
Salim, uh, do we, for example, can we count, for example, actions of animals, for example, steps, like sound of steps, and sound of actions as anthrophony?
Yeah, so I think of anthrophony as mostly the sounds made like by machines,
Mm,
human-made machines. Um, so and this is students actually do ask because there are those like nuanced
mm,
cases, uh, like if an animal is inside of a machine, if a mouse is scuttling inside of a house, is that an anthrophonos sound?
mm,
I mean, those are like these, and this is a great kind of an example of what a student might ask. And what I would say is, I try not to let the students get too caught up in those little nuance cases. I say, how if you can describe it and define it in such a way, as long as it's clear to everyone how you're explaining it, I think that that's fine. Um, Overall, I would say if it's a machine, it's an anthrophonous. If it's a human-made machine,
mm.
it's an anthrophonous sound. If it's made by a living non-human, it would be biophonous. Uh, I'm
Okay.
talking, it's a biophonous sound.
Mm,
The whirring of my computer is a anthrophonous sound. The wind at my window is a geophonous sound.
mhm.
And we're able to, our ears are really, really good at being able to distinguish individual sounds and uh, and categorize them pretty well. We're actually able to categorize what sounds and which one they likely are. If I asked you to think about think about a lightning storm or a thunderstorm, you can hear it in your mind at the moment. Likewise, if I said, like, picture the sound of a jackhammer, you can picture that sound, and we're all pretty much thinking the same sound. Biophony is a little bit different because there's so many varied sounds. There's the greatest amount of variation will be in biophony, just because of so many different species and they all have evolved different modes of expression. So, all right, please continue.
Mhm.
Thank you. Yeah. So this is where you could get into sort of the physics, and this is interesting because you were able to visually represent sound by thinking about frequency and amplitude, and those are visual ways of identifying variation in sounds. We can say, for example, the well, let me ask you, Sabina, what would you say about the loudness of
Mhm.
anthrophonos sound? Actually, which one would you say on average would probably be the loudest?
Amplitude, no? Mm.
Biophonous, geophonous, or
Ah, 어, no, diaphanous 그랬죠. Diaphanous.
yeah, so I would say that the frequency for biophonous sounds is going to be varied the most because just like you can talk fast or you can talk slow, the frequency of the sounds will vary the most in biophonous sounds. Uh, Overall, the amplitude of anthrophonos sounds of machines tend to be very, very stable and static, whereas biophonous sounds, the amplitude will vary tremendously. Just like you can raise your voice real high or go down real low, there's a lot of potential amplitude for biophonous sounds. And so we can visually represent that and then distinguish these sounds in an ecosystem. And, I like to think about the sounds in an ecosystem like an orchestra. So if you're listening to an orchestra of classical music, all of the music is playing in harmony when it's healthy. So the violins and the piano and all of the other instruments, they're playing together in harmony. If one of the sounds is not in harmony, then it affects the total experience of the symphony. Just like one, and forgive me, I don't know a lot about music, but one out of tune violin, pretty much everyone will notice if in the symphony because they're all playing together. All right, please continue.
Mhm.
Yeah. I want to see if there's a way. Give me one. I'm gonna one moment, if you don't mind. I'm gonna see if I can send you. I'm gonna Nurse Hassan, I'm gonna send you a link
Okay,
to.
you can send to here
Yeah,
to the chat.
yeah. All right.
Just let me share the screen once again with shared sound. Yeah.
Can you play that sound for the audience, for everyone? And then just like you all to try and
Okay.
describe the sound as you hear it. Do you see it? The link?
Yeah, I see the link. Mm,
Yeah, perfect. All right. So everyone try and listen to this and then just try and describe it however you feel. But if you're at a loss for words, ask yourself just to describe the loudness and the amplitude of the sound if you can.
okay.
I'm sorry for the I think yeah, you just give it I know it's annoying.
Mhm.
No, I think you have to give it you don't have to give it your birthday, just give it a date.
Okay.
No, give it, you have to be a little older. Just say
Okay.
1980 or something. Yeah, that's fine. Yeah. And you have to tell it that, yeah. All right.
Okay.
Here, press. Yeah, okay. So
Did you hear it?
press pause on the bottom. It's yeah. Oh, there we go. Yeah. How many different sounds do you think you heard? Just whatever you just tell me as you're listening, or describe a sound as you heard it.
So teacher, may I answer?
Yes, please.
Yeah.
For me, it's at least two. The first one is folding a paper a lot of times, and the second one is rain.
That's excellent. I love that. Yeah, you're right. It does sound like crinkling paper, kind of.
Yeah.
You're absolutely right. I've never thought about it like that. That's excellent. And yes, and the other one does sound like rain. Absolutely. Do you mind if we listen to it one more time?
Okay.
And I'm going to give you no, just
What I want most for my daughter is for her to be happy.
press the
This is
bottom
the
down.
story of
Sorry.
Mm-hmm.
Does it let you rewind it or something like that? I don't. Maybe you press on the bar. No, just yeah. No, press on the. Okay. Yep. Did
You
anyone
got
hear
it now?
other sounds?
I hear the crashing of the dry leaves, maybe.
Okay.
And
Yes.
also like water bubbles.
Mm-hmm. Excellent. Yes, you're right. The bubbles, that is definitely a very clear sound. And that crinkling of leaves, yes, you're hearing some great sets of sound there. There's a couple of underlying tones that are also there. There's a kind of like a almost like a ribbit sound that's really, really subtle. I've heard this a bunch of times. This is why I'm able to distinguish that. But what you're hearing there is a healthy reef. What you're hearing is a mix of geophonous sounds and biophonous sounds. That frying bacon sound is actually the sound of the sea life sort of just moving around inside of a healthy coral reef. So if that's a healthy reef, what would you and imagine an unhealthy reef sounds like? How would the unhealthy reef sound different? Let's there's time. I gave you a second one that let's listen to the second.
Mm-hmm. Okay.
I send you another in the shared chat.
Yeah, I got it.
Press. I don't know what's. Oh, no, press back. But you heard it the first time. Okay.
Okay.
All right, that's
That is the
so.
right sound?
Yeah, this is it.
Students, do you hear the difference of these two sounds?
Actually, no.
Not much.
Okay, that's
Mhm.
interesting. And this is actually really interesting. So I think that this goes a lot towards understanding how we tend to get information. We're so visually oriented that trying to distinguish between sounds is actually very difficult.
Let me
This is
play
often
once again the healthy sound, like healthy coral reef sound. This is what unhealthy. Do you hear the difference?
I think the difference is in amplitude, the level of loudness.
Absolutely. So the unhealthy reef is a lot quieter. Why?
Uh,
Maybe there is no diaphanous sounds, only diaphanous.
Okay,
Maybe
yeah.
that's
So
why.
you're absolutely so now that you are absolutely right. Now let's paint the picture and explain why. So if the ecosystem is damaged, what's happening?
Should I move ahead?
Yeah, please.
Yeah.
Fish go away, maybe.
That's exactly right. So if the ecosystem is damaged or unhealthy, then the species that used to be there are not going to be there because there's nothing to support it. So you will have it will be quieter. There will be less variety of sounds. Now, we might not have the sensitivity because we're not used to listening to sounds in a coral reef to immediately notice that difference. This is where technology is able to help us understand the total diversity of sounds that we could be hearing in there. Um, so what you sort of and obviously depending upon the age of the students, the level of rigor of what you would expect for them to describe would vary. What I would expect for my middle school students, my eighth grade students to be able to describe is I would make them listen to it a bunch of times until we could pick out 5 or 6 different sounds. I tell them a specific number so that they're actually looking to try and distinguish that level of sounds. And then, so like the sounds of what's left are predominantly geophonous sounds. There are a couple of biophonous sounds, but they're basically species that are able to live on very limited resources that are left in an unhealthy reef. So fundamentally, what you sort of come away with, and what I have my students come away with, is this idea of okay, in a healthy coral reef, we will hear a greater variety of sounds, and we'll hear a significantly greater volume of sounds. So it's all well and good for them to be able. Yeah, please continue looking down. So there's value in understanding the differences in an ecosystem in a coral reef, but the reality is most of us are never going to go see a lot of coral reefs. So I introduce this as an interesting place, but then I want them to extend this activity. What can we generalize about sounds and about overall health of an ecosystem to other environments? What can we say about biophonous sounds, biotic and abiotic, living and non-living sounds in environments? Well, they will
For
vary
example,
depending. Sorry.
if forest is sound, is healthy, there will be a lot of animals like deers, bears, and so on, so on, so on. And if it was damaged, for example, there was a fire or something
Mhm.
like this, animals will go away from the system, and it will be empty.
Yep, that's exactly right. And so this is a non-invasive way of us to be able to uh, keep track of ecosystems. And one of the wonderful things about this idea of soundscapes is soundscapes are just like an environment. They change throughout the year and over years. So this is a way to collect a tremendous amount of data about a changing environment without having to extract resources from it. So we don't have to like sample animals. We don't have to trap animals to understand something about the overall health of an environment. You can collect sounds from an ecosystem. You can have a recording device, leave it in an environment, and see how the sounds change throughout the year. How do we uh, 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 I don't know, forgive me, I don't know anything about like nearby forests where you live, but imagine uh, having a recording device in a nearby forest where you're able to hear how the sounds change every month. And then what what are the possibilities there? And this is where I have students design, not necessarily do that, but design an experiment or a data collection. So a student might say, I want to know how does the sounds of my block change every day? Well, they could record the sounds on their block every day for however long, and then we can characterize the differences in the sound and try and extrapolate something about the changing of the environment over time. We can do this in environments and to not only characterize it in a long time, but then characterize the reduction or the increase in particular sounds. So we can say something about the changing biodiversity of an environment in by recording data. And you can create a library of data for years. So if this is basically something that's just starting as environment, as we start recording these sounds over years, we're painting a picture of how an environment changes. And so, in some ways, this is only possible thanks to AI being able to analyze sounds and then be able to help us characterize the changes, because we're not good at necessarily being able to individually make those distinguishments, but the technology that we have now enables us to do that and paint a richer picture of ecosystems. And this is something that students are capable of doing. Not very well, but their phone, they can record sounds, and and especially if you are living in an exotic or unusual place, this is a great way for citizen science, where there are websites that like it's one called Xenocanto, where you can record bird calls or sounds that you hear in an environment, and you can then create like citizen depositories of sounds, and then we can see them changing over the years. So as a way to examine data that students can actually get themselves and contribute to the scientific community, this is a safe, non-invasive, inexpensive way for students to observe and capture and then offer a contribution to science. You're not going to have a CERN super collider in your school, but you can get inexpensive soft sound capturing equipment, or even just use your phone, and you can start capturing that and then sharing it and analyzing it in your classrooms. So I'm more than happy to answer any questions about this lesson, or about how I use it, or about just teaching middle school or high school in general. I've taught biology, I've taught chemistry, I've taught math. So I'm more than happy to talk about any and all of those things if you have questions. And also don't feel like obligated to ask me. If you don't have questions, that's also fine.
So may I ask a question about
Of course.
this?
Yes.
So I came up with a thought
Yes,
that
please.
sounds will also change with seasons. For example, a lot of birds will fly to the north or south, depending on the region,
Yep.
when fall or winter appears, and some animals will go to sleep. And so the total noise in the forest will decrease also
Yes.
with seasons.
Yes, it's exactly right. And depending upon the sensitivity of the tools that you are using, you can say, I'm hearing a 10% decrease in the total number of warbler sounds, the sound of a particular bird. And so it's very difficult to get an accurate number of how many birds are in a given area. But with soundscapes, you can measure a change in the sound, which can correlate to a change in the population over time. And it also is a way to identify new species. If you capture sounds that have not been categorized, then very likely there are species that you are not familiar with. And through soundscape technology, new species have been discovered. Even if they haven't been seen, they have been discovered because it's like, okay, this is a sound that it sounds like other species, but it's not quite. So we're suggesting that suggests here's a place to explore to try and discover a species that we can hear, but we have not yet seen.
Selim, I see, like very perspective future of this.
Mhm.
Do you know someone who deal with this, like some scientists in the world?
So Yale. So again, I don't want to like suggest that this is
Mhm.
not my area of expertise, but I know that Yale, for example, has a soundscape um, part of their School of Forestry. Uh, does a lot of this work. And Cornell University, Cornell is probably the foremost that I'm aware of anyway, um, uh, uh, on the study of birds. Their ornithology
Mhm.
program has such a beautiful library of bird sounds. And this is, and even if you don't want to necessarily try and capture soundscapes yourself, the library of sounds that are out there for hearing these animals. It's a wonderful way for students to pay close attention. And this is actually something I think that's really important because we're so used to visual feedback. Getting kids to be quiet for 30 seconds to actually listen is a skill that they very, very much need to develop. So, like when they hear the sounds, they might laugh because it sounds funny. But it's like, no, no, fine, enjoy it, but okay, pay attention. What are you hearing?
Yeah, like, in Kazakhstan,
Hmm.
students also for example, school students do some kind of projects, and I think this is a very good idea to do a project with students. You may create some kind of artificial intelligence based sound analyzing system, and present it to the project. And I think it's very compelling. Yeah, like also, uh, if someone works at school, so please welcome to take this idea and like uh, you can create like you can do everything, every experiment you want, isn't it?
I don't know nearly enough about how I would create a way to analyze it, but I mean that if your students are able to do that, well, they're far more advanced than most of
Mm,
my students. But I absolutely think that from a collecting standpoint and analyzing, this is an area that is ripe for students to explore. Um, Pictures are great, but this is just a different way of uh, paying attention. Uh, you know, um, One of the things that I think that 21st century students, because they're so addicted to these things, um, their attention span is so minimal, and sound requires a lot of concentration. Just like we're all paying attention and we were all struggling to hear the differences in the sounds at first. So this is a tool that also enables them to improve their attempts at consciously paying attention to what is in front of them. And also, sorry, one more thing, figuring out how to describe what they're hearing is also its own challenge. Uh, Coming up with ways of describing things uh, so that other people can understand them is an important part of scientific communication. And I think that this offers, I always say strip science of the fancy vocabulary and what is it that scientists are doing? They're attempting to observe reality as accurately as they can and then explain what they've observed as clearly as they can. And if you do those two things, you are engaged in science. You don't need a lot of equipment. You don't need uh, a lot of degrees. Uh, if you can do those two things, you're doing science. And this is something that sixth graders, seventh graders, however old your students are, they can do.
okay. So students, do you have questions?
totally fine. Actually, if you don't mind my asking, what levels or grades do you teach or will you teach? Whoever.
They can teach middle and high school.
Okay.
Yeah.
Wonderful. Yeah. So, that's the other thing about this kind of activity is you can increase the rigor depending upon the grades. What you can ask of a middle school student, it might just be record some sounds around your house and tell us what, and then categorize it by geophanous, biophonous, or anthrophonous. And then maybe a high school student might be, okay, let's look at take the sounds, put them in a spectrogram, and then describe them in terms of the amplitude and frequency. And then you can do all the physics related to that.
Okay. So
I,
students.
I have a question.
Yeah, wonderful.
The topic that you have taught us, is it a part of curriculum of the students, or you just found a unique way to make the student concentrate?
So in New York public schools, they do have a mandatory curriculum that they have to cover. This is not a topic that would be part of that. I chose this to research because, so I'm a science teacher. I'm not a researcher, but what I want to be able to do is bring scientific research to students. So when I discovered this, I wanted to understand it so that I could explain it so that students could do it. I think of this as I use this when I'm introducing ecosystems in my class. So when I do an ecology unit with my students, this is a way of interacting with an environment. So I'm not taking them to Australia. And yes, I could show them a picture, but I think this is more interactive than just showing them a picture of a coral reef or watching a video where someone lectures to them about it. This makes they have to figure something out. I'm giving them a problem that they have to solve. And in biology, it's hard to give problems to solve. This is, I think, one of the challenges with teaching biology is we don't tend to have first principles teaching. We tend to just tell them what is true, and then they have to take our word for it, unlike in physics or chemistry where they can observe it for themselves. This is my attempt at getting them to observe things for themselves and then explain them. Does that answer your question?
Yeah.
Great.
Thanks.
Oh, my pleasure. Okay, well, if there's nothing else.
Any other students? Any other students have questions? Okay. So, Selim, I really appreciate your time and effort, and thank you for accepting my invitation.
It's my pleasure.
Yeah. So, students, we can take a break.
And
we can take a break.
I think I will be back again at some point.
Yeah. Selim is going to share us maybe next week also another method of teaching, like it's about drawing. In physics, we use drawing like mechanisms and some other stuff. And so, he's going to share his experience of drawing in teaching science. I think it's also very valuable. Yeah, this is, I think, this is one thing to think about. And now you are informed about the sounds effect and what can you include in your curriculum through me and Selim. And from today, you are going to think about that. Yeah. And you are going to try to, see differences in curriculum and approach it from different side than usual teachers do, This is our message to you. And I think we reached our aim. And I think like we just, you know, we are not telling you advice. We just telling you some kind of, you know, new things that can be happen inside the classroom that make you very creative and help you rise a gifted students.
May I give a homework assignment?
Yeah,
Just
sure.
listen today, tomorrow, listen, try and find sounds that you try and distinguish different sounds in the environment. Try and see how many sounds you might notice. Our brains filter so much out. So just try and say, okay, I'm outside, I'm hearing 3. Oh no, I'm hearing 4, I'm hearing 5 different sounds. Just try that for even a minute and just see what a variety of sounds are around you.
Okay, thank you so much.
Thank you very much. It's a real pleasure. I really
Yeah.
appreciate all of your time. Thank you all.
Yeah.
Take care.
Students,
Thank you very much.
Thank you.
let's take
Thank you so much.
Thank you.
Yeah,
That
it
was
was
very
really
informative and
interesting.
insightful.
We appreciate it.
Thank you very much. I really appreciate it. All right, Nur Sultan, you're back as host.